My name is Mackenzie Leake, and I'm a METEOR postdoctoral fellow at MIT CSAIL. I'm currently working in the HCI engineering group led by Professor Stephanie Muller. My work largely sits at the intersection of computer graphics and human-computer interaction, and I focus on building design and media authoring tools. A lot of my work recently has been in the topic area of quilt design. And at first, people might be a little bit surprised to hear about quilting as a domain in which you might think about computer science or building computational tools. But I think in that domain, it turns out that there's been a lot of really interesting challenges in geometry and design. And there have been a lot of opportunities to think about kind of understanding this long, very traditional craft process and thinking about how we can understand what people are doing there and make some design processes easier. So one area we've thought about a lot has been this topic called foundation paper piecing. And that's a type of quilt making technique in which you sew fabrics directly to a sheet of paper. But in doing that, you end up with a lot of constraints. So you end up with a lot of types of designs that you may or may not be able to sew using that particular process. And it's something that it's a process that lots of quilters like to use. It gives them a lot of different types of designs. The paper gives you all of this kind of stability and precision and things like that. But designing these types of patterns is exceptionally challenging. So we've been thinking a lot about how we can understand the mathematical foundations of this design process and build tools that let quilters focus on the visual design, but not have to worry about some of the more tedious ordering steps or checking constraints or things like that. So with our software, we allow users to essentially sketch a design in a web-based tool. It works like a standard SVG editor you might be familiar with, like Adobe Illustrator or something like that. The user kind of clicks and drags and drops lines, which represent seams. And as they're going through and designing what they want their ultimate quilt to look like, under the hood, the tool is calculating the order in which the user would need to sew the pieces. The tool will alert a user if a design isn't able to be sewn in this way. The tool will also help the user break down the design into different, what are called sections, if it has to be broken down on multiple sheets of paper. And so the idea with kind of using the tool is that the user can sketch the individual lines, focus on the visual design, but the tool does all the hard work of computing the possible orders and checking the constraints and things like that. So at a very high level, I think that this idea of combining a very deep understanding of expert practice with computational tools that represent how experts are thinking about a problem, how they're working through a problem, I think that can be applied to a lot of domains that are inherently open-ended. I think that we've done a lot of work in computer science of representing domains that have kind of win-lose states. It's kind of very clear what success looks like and so forth. And I think that we're just getting to this point where we can really think about these domains that don't fit into that space, that have more open-ended structure and figuring out what the right way to represent the problem is, what the right way to break it down is. I think that's really the challenge ahead. I feel really fortunate to have been in the METEOR program this year. I've really enjoyed my time at MIT and in CSAIL, and specifically in the HCI engineering group. And I think something that has been really nice about the program being so small is that it's also been incredibly personalized. The METEOR program was a really good way for me to think about what my goals are and to learn a lot about lab management and the other side of being a faculty member. Not just thinking about your own research project, but how to advise students on a range of projects, how to fundraise a lab, how to set a longer-term vision and things like that. And I think that having that mentorship from my PI as well as other faculty in the department has been really helpful for helping me kind of decide what types of places to apply to, what type of lab I might want to run, and to kind of have that mentorship experience where I feel like I can walk into that job and I will still have a ton to learn, but at least have a little bit of experience with those things that I wouldn't have had straight out of grad school.